Hello triple students. So this lesson is only for triple students. It is extra content that the triple students have to know. So if you are a trilogy student, stop the video. You don't need to do this lesson. So for the triples, we are looking at alcohols today. Okay. So alcohols. For your specification, what AQA expect you to know? We've got the alcohols contain OH, the names of the first four in the homologous series. You need to be able to name them. You also need to describe their reactions with sodium, combustion, adding to water, oxidizing agents, and the main uses of alcohols. You also need to know how ethanol is produced. So we need to know how we can ferment using yeast, and also adding steam to alkenes as well. Okay, so alcohols either showing the formula or the structural displayed formula there. So we'll go over all of that in today's lesson. So first of all, alcohols are not hydrocarbons. Okay, so remember the definition of a hydrocarbon is something that only contains hydrogen and carbon. Alcohols aren't hydrocarbons because they contain oxygen as well. Okay, so alcohols have the functional group OH on them. So they have an oxygen bonded to a hydrogen. When we name alcohols, their names end in ol. So for example, ethanol. You'll have heard of ethanol and probably methanol as well. Okay. We normally use alcohols on the whole for fuels, so we burn them, and for solvents. So that means we dissolve substances in them for their use. For example, some alcohols are used as the solvent in kind of aerosol sprays, so deodorant, hairsprays, and things like that. They're also used in paints and other industrial liquids where the alcohol will evaporate off later on, leaving a dried paint, okay, dried pigment. So they might ask you uses of ethanol or uses of other alcohols. So this question is asking you two uses. Okay, so the mark scheme is allowing fuel, solvent, antiseptic or antibacterial. Okay, I know that we have in my house we have 98% ethanol, which is not used to drink. That is very dangerous. It's actually used as a cleaning fluid. So you water it down with water, and you use it as an antibac cleaner for surfaces like in your kitchen or your bathroom. Okay. So with our alkane topic, we know the prefixes. Same with our alkenes, if you've done that lesson already. See if you can remember the prefixes for the amounts of carbon atoms in your chains for the first 6 carbons. Pause the video, see if you can remember them. Okay, we'll go through the answers. So 1 carbon is meth, 2 carbons is eth, 3 is prop, 4 is bute, 5 is pent, and 6 is hex. If you can remember your mnemonic for that, monsters eat pupils but prefer hamburgers. We want to name our alcohols. Okay, so we know they're going to start with our prefixes. We know from the information we just learnt, they all end in ol, O-L. Okay, So we know ethanol. Hopefully from that we can put together methanol, ethanol. Okay, pause the video, see if you can write out the next 4 alcohols. Okay, let's go through the answers. We've got propanol, butanol, pentanol, and then hexanol. Okay, so we want to be able to draw our alcohols. We need to draw their structural displayed formula. Okay, so we're going to draw the same as an alkane, but we're going to replace one hydrogen that's on either end, okay, with an OH. Okay, you can draw the OH with a bond in between the O and the H, or without, so without down here, but you can put a little dash in between them as well. Okay, there is a bond between the O and the H, but it's a little bit simpler to draw it like this. Okay, so when we write out the formulas, we write out the formulas how the alcohols are structured. So we don't have a general formula. So with alkanes, we had that general formula of CnH2n plus 2. Alkenes, CnH2n. Alcohols, we don't have that. Okay, you could make one up, but it's not how we write them, because when we write them, it shows what their structure is. Okay. So I'm just going to show you the structures for the first 3. See if you can draw out the next 3 structures. So pause the video, draw them out based on their names. Remember, the more times you do this, the better you're going to do at remembering them and putting them into long-term memory. Okay, so these are our next 3 alcohols. Okay, notice all we're doing is adding a CH each time, somewhere in the middle. Okay? Now when we write the formula out, we're not going to say how many carbons there are, how many hydrogens there are, how many O's there are. Okay? We're going to write out how it's structurally formed. So for example, over here, we've got ethanol. No, not ethanol, methanol. This is ethanol. So we have methanol here. We have CH3OH. So we write the formula like this, CH3OH. That's showing you that you've got 3 hydrogens coming off a carbon and then an OH. For ethanol, we start from the left, we've got CH3, CH2, OH. So it should look like this, okay? And then every alcohol from then on will follow the same pattern, but every time we increase the carbons, we're going to increase the hydrogens by 2, so we just put another CH2 in the middle, okay? So for example, the next one, we could have CH3, CH2, CH2, OH. So we've got the first 2 formulas there. We've also got the displayed formula for all the alcohols. See if you can write the formulas out. Pause the video, have a go at it. Okay, let's go through some answers. Okay, so propanol with 3 carbons in our chain, CH3, CH2, CH2, OH. Butanol, CH3, CH2, 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 OH. pentanol, CH3, CH2, 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 OH, and hexanol. You can read that out for yourself. Okay, check your answers, give yourself a tick if you've got them correct. Okay, show off your hard work. So you're expected to know how alcohols react with a number of things. Okay, the first thing is with sodium. Okay, so a group 1 metal. You know group 1 metals react with water to produce hydrogen gas. Okay, sodium reacts very similarly with alcohols as it does with water. So it produces hydrogen gas and it also produces a salt. Okay, you are not expected to name that salt. Okay, but it is worth remembering how it happens. Okay, so we have sodium methoxide, sodium ethoxide, sodium propoxide, and sodium butoxide produced in each of those 4 reactions. Okay, now it does only state the first 4. It's not something that they could ask extra of with you. Okay, they couldn't ask 5 or 6 carbons in a chain length for this one. Okay, so they could ask you a simple tick box question like this. Okay, so hydrogen is produced. Now, looking for questions in past papers that are to do with the reactions of alcohols, they don't come up a lot. So if it's not something you understand and you're not aiming to get an 8 or a 9, then it's something that you can not worry about not understanding. But it does come up, okay? So you're also expected to know how alcohols combust. Now, in the series of lessons, there is a lesson on combustion, okay? So we did, for the main lessons, there was crude oil first of all with fractional distillation, then alkanes, then combustion. So it's the 3rd lesson. So if you're watching this video before you've watched the video on combustion, stop the lesson, go watch the combustion lesson, then come back and have a look, because otherwise it might be a little bit harder to know what I'm talking about, because I've explained a lot of this in the combustion lesson. Okay, so alcohols normally undergo complete combustion, so they normally burn quite well, so they're quite flammable. They're also quite clean when they combust, meaning that they only produce carbon dioxide and water and not other things like carbon monoxide or carbon. They could undergo incomplete combustion if there's not enough oxygen around, though. So you're expected to be able to write out the word and symbol equations for the first 4 alcohols and their reactions with oxygen to produce carbon dioxide and water. Okay, you're expected to be able to balance them as well. So if you're unsure about balancing, it might be something that is remembered. Okay, so you could remember these numbers for balancing. But the best thing to do is, if you've got a younger brother or sister or some toys left over from when you were younger, if you've got any Lego sets, try making methanol and oxygen by joining some bricks together. You can do different colours for carbons, different colours for hydrogens, different colours for oxygens. See if you can make it out. In school we have molly mods, so we'd be able to do it with molly mods, but obviously at home they're not available. So have a go at doing that. That might be worth while, and it might help you remember how to balance equations as well. They might ask you to fill in the blank. For example, here we want to fill in oxygen in our equation. They might also get you to fill in a balanced symbol equation. Now this question is saying carbon dioxide and water are produced, so you just have to remember their formula, so CO2 and H2O. But they are asking you to balance it as well. So 1 mark of this 2-mark question will be for putting carbon dioxide and water's symbols on lines. The other mark will be for balancing the equation, okay? So the answer, we have 3 lots of O2, 2 lots of CO2, and 3 lots of H2O. Now you are allowed, if you do this way, to put a 2 in front of this, a 6 in front of this, 4 in front of your CO2, and then a 6 in front of your H2O. You are allowed multiples when doing balancing, okay? So that's doubled everything in the equation, if that makes sense. So you're also expected to know how an oxidizing agent reacts with alcohols. Now normally, for triple students doing the higher tier paper, you think of oxidizing as in oil rig, so is loss of electrons. But oxidizing also has the foundation definition of where oxygen is added. That is what an oxidizing agent will do. It will add oxygen, okay? So we have an alcohol on the left-hand side, so we've got ethanol here. We're going to add an oxidizing agent here. So this is potassium chromate. So you don't need to know the reagents for this. So you don't need to know the oxidizing agent. You don't need to know the conditions. You don't need to know that it's in an acidic environment. That's what the H plus means. But you do need to know that a carboxylic acid will be formed. So we've got ethanoic acid here. So 1 hydrogen has been removed. No, not 1. 2 hydrogens have been removed, and a oxygen with a double bond has been added on. This part here, the C double bond O and the COH, is the functional group for a carboxylic acid. Now you will learn about carboxylic acids in another triple lesson, okay? That's the next one that will come out. So we've got an exam question here. It's worth 3 marks. Pause the video, have a go at writing out 3 marks worth. Now don't worry about the lines. For every mark in an exam, they have to give you 2 lines of space to fill. So this is worth 3 marks, so they've got to give you at least 6 lines to fill. You don't have to fill them. Don't worry about that, okay? Pause the video, see if you can figure out those 3 marks. Okay, so our 3 marks come from the fact that air contains oxygen. Oxygen oxidizes the ethanol, or the ethanol reacts with the oxygen, and you produce ethanoic acid. Ethanoic acid is vinegar. Okay, like the question says up here. So that's your 3 marks. Mark yourself, see what you got out of 3. Okay, you might get a question about ethanoic acid being produced from ethanol. What type of reaction produces ethanoic acid from ethanol? Okay, we want oxidation. You're not allowed to put redox. Okay. Okay. You're also expected to know that alcohols can be added to water. Short chain alcohols like methanol, ethanol, and propanol can dissolve in water. They're not great at dissolving, but they can. The longer the alcohol chain length becomes, the less soluble, so the less dissolving it becomes. So you end up with a visible layer. Now that visible layer can happen with the short alcohol chains like methanol, ethanol, and propanol if added to water, if you add a lot of it. So don't add water to any alcoholic drinks as you end up with a layer of water on the top. Okay? Now you are expected to know how we produce ethanol. Okay? Now ethanol, something you're not meant to drink on your own until you're 18, apart from if you're in your own home with your parents' permission. Okay? You're expected to know how we make ethanol though, how we produce it. So there's two main methods. We can ferment sugars and produce ethanol, or we can react ethene with water or steam to produce ethanol. Okay, you're expected to know the positives and the negatives of both methods, and we'll go through those in a bit. So on the screen right now, you can see a couple of examples of alcoholic drinks that contain ethanol. So you've got a vodka here that's produced from potato starch. So they'll use the potatoes, they'll add some yeast, and the yeast will ferment the sugars found in potatoes, the glucose, the starch, into vodka. Beer is produced in a very similar way. They use a fruit or vegetable, I'm not sure actually, hops. It grows on vines like grapes, and the hops are added with yeast and sugar as well, and that allows the yeast to ferment and produce the ethanol. On the right hand side, you've got some wine brewing here. So again, grapes, and you might see some of these if any of your parents do home brews. These are little locks on the top. What they have is they have a little bit of liquid in here, like water, that allows carbon dioxide to bubble through. So the carbon dioxide produced from fermentation can be released, but no air can get back in. On the left hand side here we have a still. Okay, a still is it's a copper still made out of copper. It will distill the alcohol and take off the pure alcohol, which is why we can get very high alcoholic content beverages like vodka. It says 42% alcohol there. Whereas other beverages like beer, you only get about between 5 and 10% really alcohol. Okay, so during the alkene lesson, that is I think the fourth one in the list, you learn how ethene and steam react. Okay, we have a phosphoric acid catalyst, we have a high temperature and high pressure, and we have steam. Obviously water is turned into steam above 100 degrees, and that reacts with ethene to produce ethanol. The H2O is split up into OH and H. One H joins on one side and the OH joins on the other. There's some positives to this. We only have one product, so there's no byproducts that we need to think of how we need to release into the world. So there's nothing produced that can pollute our atmosphere or our water. Ethene is a byproduct of cracking, which you'll learn about in your 5th lesson for organic chemistry, but it is an alkene, and that can be used as a way to get rid of this byproduct of cracking. Our fermentation is a little bit more complicated, although it's a simpler method. You don't need big, heavy, pressurized containers. You just need a container that you can keep anaerobic, which means don't let any air in, no oxygen, okay? You're going to have to add some yeast to your feedstock. They're going to use the sugars dissolved in warm water to produce carbon dioxide and ethanol. Sorry, my screen there is wrong. Let me just change that. Best laid plans of mice and men ever work. There we go. So our yeast is used to produce ethanol and carbon dioxide. Now, yeast like to be between 25 and 35 degrees to work best. That's their optimum temperature, okay? When about 15% of the solution has turned into alcohol, that actually kills the yeast. So fermentation, you can only get about 15% of your solution as alcohol, which is why we have wines, beers, and kind of other drinks like cider are less than 15% alcohol, because they use fermentation, and fermentation doesn't get that much alcohol, so you can't get a strong drink. You can fractionally distill your solution to separate the alcohol from your solution. You can filter off the yeast and be left with the liquid and the alcohol, which is where beer and wine come in. Okay, they normally use yeast sedimenting down the bottom. So on the board there, you've got lots of either advantages or disadvantages for steam reacting with ethene and fermentation. What I want you to do is sort whether it is an advantage or a disadvantage and place it into the category of either fermentation or the ethene reacting with steam. Okay, so pause the video, have a go at that. Okay, so on the left we have fermentation. Okay, so fermentation, it produces impure alcohol, ethanol, which needs to be purified by distillation. So that distillation process is going to use up some energy. So that's a disadvantage. Now, fermentation is a batch process. That means you do the reaction on a certain amount of produce in your reaction vessel. You get your ethanol, you take it away, you clean all your equipment, and then you do it again in another batch. Okay, that is more labour intensive, so that's going to cost you money in terms of wages. Okay, it's also going to take more electricity to clean out your equipment, to stop the process. You're going to waste time for the cleaning as well. So that's a negative. We've got a slow reaction, so it's not brilliantly quick. We need to allow things to ferment, so sometimes days, sometimes weeks. We need a temperature around 30 degrees, so that's not that hard to do in terms of energy costs. And fermentation, it uses feedstocks such as corn, sugarcane, rice, etc. So you've seen potatoes. And all of those are renewable resources, so we're not going to run out of those. That's brilliant. We can continue making ethanol forever. They can also be seen as less polluting, as when the corn, sugarcane, rice, etc. are growing, they are photosynthesizing, so they're removing carbon dioxide from the atmosphere, they're storing that carbon dioxide, and then when they are fermented, they're releasing that carbon dioxide back into the atmosphere. So it's seen as carbon neutral, which means there's no extra carbon being added to the atmosphere. The other side, we have ethene plus steam, okay? That produces pure ethanol. That's brilliant, that's really good, okay? Obviously 100% ethanol, you cannot drink that as a human, okay? Really dangerous, but it can be used as a starting material for lots of reactions. I know my year 12s used pure ethanol to make ethyl ethanoate, which is an ester, which is used in nail varnish remover. So it can be used to make other products as well. You need quite a high temperature, about 300 degrees. You also need a high pressure of about 60 atmospheres, which means 60 times the atmosphere at sea level. So that's quite energy intensive. So it will use lots of electricity and energy to keep it that high temperature and that high pressure. You also need specialist equipment for that. So you can't just do it in a glass bottle or a plastic bucket. It's a continuous process, so it's less labour intensive. So you spend less of your money on wages, and it means you can continuously produce ethanol round the clock, 24/7, 365 days a year. Now, the problem with ethene and steam reaction is the ethene comes from crude oil. That's a non-renewable resource, so it can't be made in the amount of time that we use it up in. But it's a very fast reaction, which is very good. Okay, so hopefully that's kind of sorted your advantages, disadvantages to fermentation and producing ethanol via ethene. Okay, you might get an exam question like this. Got 2 parts to this question, both worth marks, so you've got 2 minutes. Pause the video, have a go. Okay, so the first part, the word equation for the reaction to produce ethanol, if you follow the diagram, it gives you a massive clue. And then it also asks what happens to the unreacted ethene. So we have the reactor, gases are cooled, we have ethanol and water being produced, and then something here. So our answers, we have ethene plus water. You're also allowed steam. That's what it tells you in the question, ethene plus steam. You're allowed that in either order, so water plus ethene is all right as well. The ethene that has not reacted will go back to the reactor and is recycled, so be used again, okay? So that's where the marks come from. So we've got a comparison side by side of the way ethanol could be made from fermentation or from alkenes from crude oil. So we've got a 2-mark question. Describe how the solution of sugar in water is used to produce the mixture of ethanol and water. Okay. 2 marks, pause the video, see if you can do it. And then we'll go through some answers. So you need to add yeast and then allow the yeast to ferment or by fermentation, okay? You're also allowed to put it in a warm place or a temperature within the range of 20 to 45 degrees or with an airlock or an absence of air, okay? And that is all you need to know about alcohols and the production of ethanol, okay? So if you are struggling with this topic, I know the reactions of alcohols are a little bit hard, okay? Maybe go find another source of information, so YouTube videos. Just make sure when you are searching alcohols, you pop in GCSE into your search as well. Otherwise, you could be searching alcohol drinks, which is ethanol, which is an alcohol. However, we use the alcohol for the whole term, and they're not just used for drinking. They're used for solvents and fuels and antibacterial solutions as well. So don't forget about that. Okay, bye for now.